All right, so 10-1 notes. Let's talk really quickly about how this is going to work. We're doing 10-1 notes today. You'll have a worksheet for homework. Then next time we'll do 10-2 notes and you'll have a worksheet. But because there are only 2 units in this, or 2 lessons in this unit, I'm not going to test you. On Friday we'll have a quiz over 10-1, 10-2, and then we'll call it good. And then move on to Unit 11. Okay? And so the only time you'll ever be assessed over this is through formative assessment on Friday. And then your final exam. Yes, Sam? When are you coming to take the test that you missed?
I can play all my track meets on 8 days.
Talk to your coach about that.
I will also won't be Friday. District.
Miss Cleveland, this is the best pre-con I've been for.
I'll be here.
We'll see. I should have it ready, but then, yeah. All right, here we go. So, couple of things. What? Whatever. Good luck keeping up. All right, P is equal to R comma theta. You have seen this before. I think it was at the very end of the Unit 6 test. We talked a little bit about this. If you'll remember the carousel problem, and you had to make a sinusoidal graph out of the carousel problem.
No.
I see all of you giving me really blank stares, so never mind. It's the first time you've ever seen this, apparently. All right, so R comma theta is how you graph polar coordinates. And polar coordinates are on this type of graph. Okay, so your R is your directed, what did I call it? Directed distance. Directed distance. So that's how far out you go. And then theta is the same old theta that we've always done. This is your angle. Okay, how far you swing out, your direction. Okay, so all along we're going to be graphing these points given a coordinate point like this. Okay, so let's just jump right into it. So, what is this 2?
How far out you go?
That's your R. That's how far out you're going. And pi over 3 is the angle. I like to do the angle first. So here, if I were starting at 0 and went pi over 3, I would swing open to this line right here, right? Well, I'm using that line and I'm going out 2 from the center. So 1, 2. There you go. Don't make this difficult. Go pi over 3 and out 2. Yeah?
Okay.
Don't make this hard, guys.
Is that it?
Yeah, I mean,
Bet.
don't make this hard.
There's a catch somewhere.
There's no catch. There's no catch yet. Okay? No, when you're graphing, it really is that easy. We'll turn it over in a second. It'll get a little more difficult, but when you're just graphing, it's that easy. Okay? Okay. Here, 3 negative pi over 6. Okay, so remember, anytime you go counterclockwise, you're going in a positive direction. I know that seems counterintuitive, but whatever. If you go down first, that's in the negative direction. So if I'm going negative pi over 6, what is that coterminal with? 11 pi over 6, right? Negative pi over 6 and 11 pi over 6 are essentially the same angle. So I go down, and then how many am I going out? 1, 2, 3. Notice that would be the same as, what would that be the same as? 11 pi over 6 and out 3. So 3, 11 pi over 6. Right? Either of those coordinates would get me to that point. Let's try one more and then I'll let you struggle a little bit on your own. Okay, so here, where is negative 3? Yes?
But if it was like the positive, like 11 pi over 6, why wouldn't it be like the line in front of it? Like how would that be true? Or like why would you start on the outside instead of like starting with?
I don't understand. Say that again, love.
Like instead of starting like right here, you went to the middle, why would you start on the outside if you're going that way? Like if it was 11 pi
You
over 6.
always start from the middle.
Oh, I don't know.
You're good?
Yeah.
Okay. Okay. All right, so here. Where is negative 3 pi over 4? Negative 3 pi over 4. Ooh, I'm hearing a lot of answers here. This is scary. Okay, now let's talk about, pause, all of that. Let's talk about where positive 3 pi over 4 is. It's right here. So I would go a full 90 and then 1, 2. So if I were going negative 3 pi over 4, I'd go a full 90, 1, 2. That would be coterminal with 5 pi over 4. Okay? Full 90, 1, 2, full 90, 1, 2. That would be your negative 3 pi over 4. Okay? But think back to physics. If you had negative direction, what did that mean? You're going reverse, right? You're going backward. So this means reverse. So here, we're at negative 3 pi over 4, but instead of going forward 1, 2, 3, we're going to follow that line backward and go 1, 2, 3. Yeah. So on your homework assignment, you're going to have to figure out 3 other angles for that. So here's one of them, and notice that both of them are negative. Okay? What is another coordinate point that would get us to that same point? 3 pi over 4. Excellent. What is another coordinate point that would get us exactly to that same point? Look, both of these were negative. Both of these were positive. So now we need a positive negative and a negative positive. This is going to be fun.
3 negative 7 pi over 4.
Oh, we're all talking. Alea?
5 over 4. No, I meant 5.
5 pi over 4. And what would the direction or the number be? What would R be?
3. Next one negative.
Negative 3. Right? So we could go the positive direction to 5 pi over 4 and then go backward to negative 3. Okay, there's one more. Yep.
We could do 3 negative 7 pi over 4.
3 negative 7 pi over 4. Very good. So what he did here is, what if we go down first and all the way around to this guy? Right? So if we just went up 1, 2, 1, 2, that would put us to negative 7 pi over 4. So that would be all 4 coordinate points to get you there. So on the homework, that's what we're going to have you do, is I'm going to have you graph this one, and then you've got to tell me the other 3 ways to get there. Okay, so that's as hard as that gets. Not terrible, right? But I want you to note really quickly, look, negative, negative, positive, positive, negative, positive, positive, negative. Right? Every combination is there. So if you're ever stuck and you can't find the other one, look at which combination you're missing and try to figure out how to get there. Yeah? Yeah. You try the next 3. You don't have to tell me. I want you to tell me all 4 on you try number 1. You don't have to do it on 2 or 3. So on you try number 1, tell me the other 3, but you don't have to on the other 2.
There's always going to be just 4 set combinations that will get you to the home line.
Yes, because on the homework I limit it from negative 2 pi to 2 pi. Now if I take off that limitation, you could go around again, and around again, and around again. But if we're just limiting to negative 2 pi to 2 pi, there will be 4.
But like, technically you could, there's like a bunch.
There are infinitely many that it's coterminal with, yes. This is so much fun, Miss Cleveland. Not everyone has taken the test in here, so I can't hand them back yet. But notice that test corrections and retests for Unit 9, which your grades are in the grade book, are due by 3/26. When is that? 19, 20, 21, 22, 23, 24, 25, 26. Next Tuesday. Next Tuesday, if you made between a 60 and a 70, come in and get your test. Do corrections, staple it to a new piece of paper. If you made less than a 60, you need to have your test retaken by next Tuesday. Your Unit 8 test, everything, corrections or retest is due by Thursday. This Thursday.
Is every time it's negative, it's always like 91 2?
I'm sorry?
When it's negative, is it always 91 2?
No. It means that you go down first and count how you get there. If you can't get the other 3, at least go plot the other 2 points. No, like here, here, and here. You're doing those 3. But then on this one, I want you to try to tell me the other 3 coordinates. Okay, I think everyone has at least graphed the 3 points. So here, where is negative pi over 3? 5 pi over 3, right? I go up 1, 2, 3 to get to pi over 3. So I'd go down 1, 2, 3 to get to negative pi over 3. Okay, so, and then it's 3 in the positive direction, 1, 2, 3. So that's how you graph that guy. Let's go ahead and graph the other 2, then we'll come back to this one. Here, 5 pi over 6, this is easy because they're both positive. 5 pi over 6, out 2. All right, over here, 3 pi over 4, but negative 2. So instead of going out toward 3 pi over 4, I have to go backward 1, 2. So I'm actually at 7 pi over 4. Okay, so up here, I gave you the positive negative. So what is another, let's just do this systematically, okay? What happens if I use a positive angle? Where would that put me at a positive angle? 5 pi over 3. Okay, and if I went in a positive angle, my r would also be positive, so that would be 3. So there's the positive positive, okay? Okay, are there any other positive angles that I could do?
No.
Yes.
2 pi over 3.
Yes, okay. I need a positive angle, right? So this is positive negative. This is positive positive. I need a positive angle and a negative. I need to go backward. So if I'm here, I would be over here at 2 pi over 3 and a negative 3. Did y'all see how I did that? Okay, which one am I missing? Negative, negative. So if I'm negative, negative, that means if I go negative, that means I have to be here and then go backward, right? So how would I get here in a negative fashion? Well, 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. That would be negative 4 pi over 3. And then negative 3. So there's your negative, negative. That's the one that always confuses people. Do we need to go back through that one?
They always have a positive.
Always. That's what I'm saying. Use it to figure out which one you're missing. Okay? Do we need to go back over how I got this one? Okay. Does everybody know that it has to be 2 pi over 3 if I'm going backward? We know that. So we're trying to figure out what this would be if I went down and around. So how would I get there down and around? Well, 1, 2, 1, 2, 3. Do y'all see what I'm doing there when I'm counting that? A full 90 degrees, a full 90 degrees, and then 1, 2, 3 spaces. So the other direction, I'd go a full 90 degrees, a full 90 degrees, 1, 2, 3. So would be negative 4 pi over 3. And then go in the opposite direction, negative 3.
So I know that we weren't supposed to do it, but like, we're going to put 2 on the try your own, like, would that be negative 2, negative pi over 6 then? Let's see.
Hold on, what?
Would be,
The other ones here would be, well, we got the positive, positive.
yeah,
So I like to get the negative, negative. So if I went here and here, that would be negative 2, negative pi over 6. Is that what you just said?
yeah.
Yes. And then that would be 11 pi over 6, negative 2. So there's my negative, 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 positive. So I must have a positive negative. So let's see, that would be, I already did that. Oh, I always read the angle first. That's my problem. Okay, so negative, positive. So that would be 1, 2, 1, 1, 2, 1. Negative 7 pi over 6, 2. Okay. That's the hardest part for kids. The graphing the point isn't hard. It's finding the other 3. Okay? And over here, we already graphed that. Do we need to go over the other 3 on this one for you? Would that be helpful or no?
Yes.
Yes. Okay, good. Let's just call it like we see it. So here's the negative, positive. Let's find the positive, positive. Okay, so positive would be 7 pi over 4, 2. Everybody see how that's the case? Right, we went around 7 pi over 4 and out 2. Okay, let's find the negative, negative. So what we're thinking about here is we're going to have to go backward. So if we went backward, where would that put me at? Bless you. 3 pi over 4. So I could go 3 pi over 4 and back 2. So that wasn't the negative, negative. Sorry, that was the negative, positive. Oh, but that's what we had, huh? Miss Cleveland, come on, kid. That's exactly what we had before. Well, hey, there's one of the 4. Let's keep going. Okay, we could go down 2, so what would that be? Negative pi over 4. 2. And if we went here, that would be 1, 2, 3, 1, 2, 3. Negative 5 pi over 4. Negative 2. So this one is the same as that one, so there would be the other 3. So see if that makes some sense to you. Oh, Miss Cleveland, this is so much fun. I'm glad we're doing this. Ryan's super glad we're doing this. Oh, okay. Here you go. Flip it over. Like I said, you've kind of already done this with that carousel problem, but never mind. All right, so x is equal to r times, what is the trig function that goes with x? Cosine. And y is r times, what's the trig function that goes with y? Sine. And these should be thetas. I don't know why I'm using x's. Sorry. And just as a fun little reminder, because, you know, you're supposed to remember your unit circle, but okay. All right, so here, if we did 1, 2, 3, remember, as long as you know first quadrant, you're fine. I taught you a trick. 1, 2, 3. 1, 2, 3. Do you all remember that? 1, 2, 3, 1, 2, 3. It always is over 2. And the numerator is always under a square root. But Miss Cleveland, I don't see these under a square root. What's the square root of 1? 1. So there are your coordinates. Right, remember we learned this? And then to get quadrant 2, you would reflect them. And to get down here, you would reflect them. Yay! Y'all remember what I teach you. Okay. Oh, we'll need this in a moment. Y'all break my heart sometimes. Okay, here we go. So we want to convert these polar points into rectangular points, okay? So take a point from here and then convert that into something on the rectangular coordinate plane. So if we were to overlay like a normal grid over this, where would that actually land us in the rectangular coordinates? That's what we're trying to do here, okay? So we're going to calculate a value for x, we're going to calculate a value for y, and that's going to be your x-y coordinate pair. So let's start with x. X is equal to, what's my r value? 2. Right, that's just whatever happens to be in front of the coordinate here. And then the cosine of pi. Ooh, this is going to be so much fun, remembering this. Okay, think about pi. Where's pi on your unit circle? You can flip it over if you need to. It's over here. What is its coordinate point? -1, 0. So what would the cosine of pi be? -1, okay, right, over here, that's -1, 0 at pi. The x coordinate of that is a -1. So x is equal to 2 times a -1. The x coordinate is a -2. Yes. Now let's do the y. Y is equal to r, which is 2, sine pi. Well, sine is which coordinate? What is the y coordinate at pi? So this is y equals 2 times 0, or 0. So here, this rectangular coordinate is -2, 0. And does that make sense? If we were to put -2 pi on your, or 2 pi, we'd go to pi and out 2. Does it make sense that that could be the coordinate point, -2, 0? That does make sense, okay? Let's try another one. Yay! It's gonna be fun. Okay, so x is equal to r, what's our r value here? Square root 3. Times the cosine of pi over 6. Well, where's pi over 6 up here? Which line is that? The first one. So it's the cosine of pi over 6. Square root 3 over 2. Oops. Whatever, I mixed those up because, you know, life is hard. There was no reason I switched those. I just messed up, but it'll still work out. When you're multiplying fractions, do the top times the top and the bottom times the bottom. Well, what's the bottom here? Okay, so this is going to be square root 3 times square root 3, which gives us 3, right? Square root 3 times square root 3 is square root 9. Square root of 9 is 3. And then 2 times 1 is 2. So 3/2 is our x coordinate. Now let's go find the y coordinate. Square root 3 times the sine of pi over 6. What is the sine of pi over 6? 1/2. Okay, so top times top, bottom times bottom. It looks like to me I get square root 3 over 2. So my coordinate pair is 3/2 square root 3 over 2. Yes. Right, Ryan? Uh-huh.
Yeah, 3/2.
Uh-huh. Say a random number on the board. Totally makes it like you're paying attention. Okay, next one. Now, no one would write this like this. What is this actually? 4 pi over 2. Do you want to try this one by yourself, the next two, or should we do one more and then you try the next one by yourself? One more. Okay. So x is equal to r cosine theta, right, well, pi over 2. I'm going to draw a little picture really quickly. Where's pi over 2? Where's pi over 2? Straight up. What is its coordinate point? Right, we didn't go any left or right, we went up 1. So what would the cosine of pi over 2 be? 0. So this is 4 times 0, or 0. Everyone see how I got there? Now for our y-coordinate, y is equal to 4 sine pi over 2. What would the y-coordinate be? 1. So this would be 0, 4. Number 7's all on you, boo! You're happy about it, too. It's okay if you say a little woo. Thank you.
Did we get on the 23rd?
What?
Did we get out of school on May 23rd?
I believe so. Graduation's on the 25th. We get out on the 23rd, graduation is on the 25th. It's a Thursday. And then Friday is graduation rehearsal, I think. Or do y'all do it on Thursday? Yeah, well, teachers are at a work day. Finalizing grades and all those hoodlums that didn't graduate on time, so we're working with them overnight to make sure they get all their credits and stuff.
Can you show your little trick up north?
My little trick?
Little.
Which one? This one?
Yes, ma'am.
Oh, you didn't write that down? Weird. Oh,
You know.
1, 2, 3, 1, 2, 3.
Yep.
1, 2, 3.
Yep.
1, 2, 3. They're all over 2.
Right.
And every numerator is square root.
Dude, that's crazy. That's actually really good, like, to trick.
Were you not in my class first semester? You came second semester.
I don't think you advertised that.
When did you come? I showed you a whole video that had 3 different tricks. There's also the hand trick. So if you're trying to get this, right, square root 3 goes on top if you're looking at this angle. Here, if you're looking at this one, 2 goes on top. If you're looking at this one, 1 goes on top. I showed you lots of these. You don't remember anything when I teach you, so why is that surprising?
I came in, like, second season.
Okay, then you would have been here for my unit circle. Oh, basta ya.
You didn't put one on the wall.
Just trying to teach the future of America here.
Estrogen's actually good for the brain.
That's why women are smarter.
Future, right?
Cleveland. What would you do if you weren't a math teacher? Become a rapper.
I mean, obviously, yes. But the rap game is hard to get into, so.
We'll talk about that at Harvard to check the rap game.
Ludacris has a master's degree in poetry.
Is that Denzel Curry has a master's degree?
If I couldn't teach, I think I'd be like a ski instructor in like Switzerland.
Oh, yeah.
Not quite different.
What's a scan?
Huh?
What'd you call it? A what?
A ski instructor?
A scan?
False.
A skian?
A ski instructor.
Oh, ski.
What?
What is he hearing?
I don't
I've never skied before in my life, but if it were a different life, I would learn how to ski and then be a ski instructor.
Why Switzerland?
Got pretty mountains that you can ski down.
Yeah.
I'd go live in Europe. There's lots of history there. Lots of math history that I could dabble in on the side as my mathematical hobbies. Right.
Ski instructor.
Since I can't teach, yeah.
Do anything for Pi Day?
Oh, I made a pie. I sure did. Chocolate with some whipped cream on top. Yes.
I saw an advertisement for Domino's. We got medium.
Oh no, see, I didn't eat pizza. No, I made a pie.
Oh, does it like sell for like $3?
Yeah, it was like $3.14.
14 cents.
Yeah.
3.14.
Oh,
Yeah, I know.
Yeah, okay. Well, Cameron was like confused why it was that.
No, I
No,
said
you
it right
you sounded
alongside-
confused.
I said it right alongside you.
Whatever. If I couldn't be a ski instructor,
A noble fisherman?
no,
I think it counts.
I'd probably be a zip line attendant in like St. Kitts. Yeah, like this
Until you
those
have
9
to-
to 5s hold me down.
You would enjoy ziplining at like King and Cindy until you have to go on the cable and rescue somebody. that's
Nope,
stuck
that would be my jam. Because they'd be like, ah! The whole time, and I'd be like, ah.
in- I'm saying like if
Be
you
a skydiving instructor.
Ooh, I could. My husband and I thought about doing that back in the day. But you have to do like 25 jumps with somebody else first before they'll let you free jump. And it's like $200 a piece. Yeah, so it'd be a lot of money. And we decided to, put that money in our 401k rather than tempting fate every time we jumped out of an airplane.
be the pilot and kick them out. Yeah.
I could be a pilot maybe next life. That'd be good. Except we gotta do math and then we'll come back to that. Okay. I see what you're trying to do. Come on. Pilot.
Pilot. You could use like angles and trajectories.
That's supposed to be a person with a parachute.
What?
Looks kind of like a leaf. Whatever.
Is it a balloon?
It's a parachute. Here we go. Next. Thank you. Next. Here we go. Serves all right. Okay, here we go. X is equal to 2 cosine pi over 6. We already talked about what cosine pi over 6 was. Cosine pi over 6 is square root 3 over 2. So this was just root 3. The 2's canceled. Y is equal to, why do you put 2 square root 3 over 2? Shame on you pre-calc kids. Shame on you.
Definitely what I
2 sine pi over 6. I bet a lot of y'all left 2 over 2 here.
You explain to me how 2 cosine pi over 6 goes to
2 cosine pi over 6. Oh, like when you were sleeping on the previous examples when we were doing this?
Could you wake me up, please?
No, that's not my job.
Okay, well,
Cosine pi over 6. What is cosine pi over 6?
let me thank myself because I
Cosine pi over 6. What is cosine pi over 6?
something to do with the unit circle.
Yes, specifically the x coordinate. Square root 3 over 2.
Wait, so is that like the
The x coordinate is cosine. The y coordinate is sine.
Okay. What you're looking at is the first part.
No, I'm trying to think of it.
Anyway, that's what it is. So then here, these will cross simplify. So you just have square root 3 over 1.
I see that a 2's canceled.
Okay. So then over here, 2 sine pi over 6. Pi over 6. Sine is which coordinate? Y. So this is 2 times 1/2. 2 times 1/2 is, whew, thank goodness. So this is square root 3, 1. Yeah.
On this quiz, are you gonna give us like the unit circle?
No? Y'all should know it.
But we will have these, right? These bad boys.
Yes.
So we still kind of have a unit circle. Just not
I mean, you should know long, short.
long.
Long, short.
Yeah, it was last year.
Same. Short, long. Taught you that too.
11 out of 10.
Taught you that too. Okay, how do we go from rectangular coordinates into polar coordinates? Because we all want to know this. Negative. Okay, so r squared is equal to x squared plus y squared. So we're going to have to do some square root action here. Yay. Tangent of theta. So if we're trying to find theta, tangent involves x and y. What is tangent of theta? Sine over cosine, which is y over x. Boom goes the dynamite. It's all coming full circle.
Wow.
Wiki, wiki. Okay, I need you to be careful though. You must consider which quadrant XY is in. Okay, this is going to be important. I know that statement doesn't make any sense to you right now, but in a minute, hopefully it will. You might want to put a circle around this or a cloud. If you've got some blinking lights that you'd like to put around it, do so. Some people have weird things in their bag. Okay. So let's get into this. We want to convert this into polar coordinates. So this right here, my x, this here, my y. Let's do our r squared first. I like to do the r first because it comes first. So I have my x value squared and my y value squared. Well, what is negative 1 squared? 1, and 1 squared is 1. So what is r squared? What is r squared? 2, thank you. 1 plus 1 is 2, my friends. Right? 1 plus 1. Whew, took a lot of work, but Fiddy got it done. Okay. Now, I don't want r squared, I want r. Square root. R is equal to whatever square root 2 is. We're just going to leave it as square root because you're not using your calculators. Now, let's go find theta. Since I only know an x and a y, the only way I can find theta with an x and a y is to use tangent. So tangent of theta is equal to my y value over my x value. Well, what is 1 over negative 1? Negative 1. Oh, that's supposed to be equal. And I don't know why I used parentheses. I got excited. Now, this little note that I drew you up here, must consider which quadrant x, y is in. Let's think about really quickly where negative 1, 1 is. What quadrant is negative 1, 1 in? The second quadrant. So what this is asking is, where in the second quadrant are we going to have a tangent value that is a negative 1? So let's stop and think for a second. If I divide 1/2 by square root 3 over 2, is that going to give me a 1? No. If I were to divide square root 2 over 2, divided by square root 2 over 2, could that give me a 1? Yes, remember your 1s, either positive or negative, are always at your 45-degree angles. That might be something worth writing down. The tangent of theta equals positive or negative 1 at 45-degree angles. Right, that was something important that we noticed when we were working with the unit circle. So here, if I know that I'm supposed to be in quadrant 2, where would I have a tangent value of negative 1? Flip it over and look at your coordinates if you need to. 3 pi over 4. That's your 45-degree angle in quadrant 2. So this would be square root 2, comma, 3 pi over 4. I love this, Miss Cleveland. This is so much fun. That's not terrible, right? Like, it's a process. What was this sound?
Contemplating existence.
Oh, well, we ain't got time for that in this class, Bubba. Specific questions? Try another one. Make sure we understand it. Okay? I'm going to find r first. So I'm going to use the formula r squared is equal to my x squared plus my y squared. Well, what is r squared equal to? 4, right? 0 squared is 0, 2 squared is 4, 0 plus 4 gives you 4. I don't want r squared, I want r, so what do I have to do? Square root. So r is equal to 2. R is super easy to find, I think. That's the easy one to find.
Question.
Yes.
Where's gonna square root it? Then why do we square it in the first place?
Because it's derived from the distance formula. If you were to just say r is equal to x plus y, that doesn't make sense. Right? 0 plus, in this case it does. Okay? Over here, negative 1 plus 1 would give you a 0. Not square root 2. Okay, so what it does is it actually gets rid of all negatives for you and turns everything into the absolute value. But this is derived from distance formula. That's where it comes from.
So couldn't you just say like the absolute value of y and x equals r?
No. Because then over here, if you did the absolute value, you'd get 2, not square root 2. You have to square root it. Yeah. Okay. All right, think about how you would find that. Essentially what you're finding is you're finding the hypotenuse of a right triangle. Okay? So now let's go find tangent of theta is equal to my y value over my x value. Uh-oh. What is this? No, right? You cannot divide by 0. This is undefined. Right? Just to go back, you had no and you had okay. Right? No, you cannot divide by 0. That's undefined. But it's okay if 0 is on top. That's just 0. Okay? Y'all kind of remember that? Who am I kidding? Never mind. Here's something new you've never learned before. Right here. Miss Cleveland, no need to get snarky. Okay, so here, we want to know where the tangent of theta is undefined. But what do I need to consider?
Where it is on the quadrant.
What quadrant we're in. So look here. 0, 2 is right here. Well, that makes it really easy. It's exactly on that line. What angle is exactly on that line? Pi over 2. So this is the point 2, pi over 2. Oh, yeah.
It's like 2 pi over 2.
Hmm? Let's try one more together as one big happy pre-cal family, and then you can try it on your own. Okay? You good? Okay. What do I find first? R. You sound like pirates. R. Okay, so then r squared is equal to 8. Eric, you paying attention here or what? Square root. But no mathematician will leave that as square root 8. How would a good mathematician leave that?
Square root 2.
Okay, good, I erased it. What, and not just square root 2.
Or it'd be 2 square root 4.
Oh, so close. So close.
We're not mathematicians, obviously.
Oh, au contraire. They're all going to grow up to be math majors and make my heart happy. Okay, well, let's think about this. What perfect square lives in 8?
2.
2 is not a perfect square.
4.
4. 4 times what? 2. Well, what is the square root of 4?
2.
So there's our R. Right? Or y'all could break out your prime factorization trees or birthday cake method if you're really super excited about it. Okay? That's good math to do. Okay, I found my R. What do I still need to find? My theta. So tangent of theta is equal to my y value over my x value. So tangent of theta is equal to a positive 1. But there are lots of places on here that it could equal positive or negative 1. So what do I need to think about? which quadrant am I in. So over here, if I'm at 2, 2, where does that put me? Well, 2, 2 is going to put me right about there. What is the angle that has a tangent value of 1 in quadrant 1? Ooh, in quadrant 1, pi over 4, right? Where in my first quadrant do I have a 45-degree angle? And that would be pi over 4. So, theta equals pi over 4. My lovely answer is 2 square root 2. Oh, did you see how I just made that work? Yes. Comma, pi over 4.
Maybe pi over 4. So I guess I got a little lost there. So as far as pi over 4, the coordinates there is, no, I remember. It's because they...
Anything divided by itself.
Is 1.
Correct.
So that's 1.
That's why all of your 45-degree angles are going to give you either a positive or a negative 1. Okay? All right. Number 11 is all you. Yes.
Back up to that bubble with the name.
Here. Yep. Number 4 is all you. Armando. Mr. Fuentes. You good? You got this one? Kind of? Okay. Some of you are not quite back from spring break yet. I'd have gone crazy had I had a couple more days. We played a lot of board games. But you can only play so many board games before you're like, gotta go stack that paper. You know.
I'm stuck.
Does that water make you smarter?
Oh yeah.
Yeah, okay. Maybe I should get some. I could use that.
Every time I drink from it, it makes plus 1 IQ.
Ooh. I need that.
See, I keep the bottle, I just keep filling it. So like I figure
Like residual IQ points, right.
it's in the bottle itself, not actually the water. You know what I
Yeah.
mean?
Yeah.
I mean, it says smart water.
On it,
So, yeah,
obviously.
on the bottle.
Right. I can be down with that logic.
Did you do raspberry applesauce?
Plus it's smart to recycle.
It is. Except we have a problem now because China will not buy our recycling anymore. So we don't know what we're going to do with it.
They won't what?
Buy our recycling anymore. We do very little of our own recycling here in the States. We sell our trash other places and they reuse it. Like
So you're saying like the country in general?
the country in general, China, will no longer buy our
I know that
plastic.
when I lived in Michigan, we would truck in the trash in Canada.
Correct.
So
Canada would pay you to take their trash for you to burn it or to recycle it or to put it in landfills.
why would Texas go to Canada when we have like places like Michigan, like bureaucracy?
Well, we process most of our own trash here. The United States doesn't have enough recycling facilities to actually do anything with our recyclable goods. So we send it off to China because think about where they make most of the recycled plastic junk in the world. China. So. All right, everybody hopefully has had enough time to struggle with this one. Hopefully not struggle. Does everybody anybody feel really good about this one? If you got 1 comma pi, you're good. Okay, 1 comma pi. I'm seeing a lot of blank stares. Okay, check plus. Half credit. let's just go through it. Okay, r squared is equal to negative 1 squared plus 0 squared. So r squared is equal to 1, and the square root of 1 is just 1. Life is good there. Now let's tangent it up. The tangent of some angle is equal to our y over our x. This is no or okay?
Okay.
It's okay. It's just 0. Calm down, right? Okay, well, once I get to this point, let's consider this. Well, think about it, guys.
How did the 1 switch to negative?
It was always negative.
I know, but if you look at the r, it's positive.
Because it's squared, -1 squared.
It's negative 1 times negative 1.
Oh, wait, oh.
Okay? Over here, as soon as I get to this step, what did I tell you to do? Plot that point. Where is negative 1, 0? Well, right there. What angle is that? Pi. So some of the time you don't even have to do the whole tangent business. Just plot that point and figure out what's going on. If it's on any of your axes, you can just use that value for what it is. This is so exciting! Right, send a representative from your table group to make your
Oh.